This video introduces OCADaMi, one-class anomaly detection and data mining toolbox. It uses machine learning and visual analytics for the detection of anomalies, and it focuses on the often encountered problem where you don't have a representative set of anomalies, which is called one-class classification. The toolbox consists of a modular framework and an application with a graphical user interface. It's used to define workflows with data preparation, one-class anomaly detection models, and interactive visualizations. It can be used to move towards a supervised scenario, since during operation, anomalies will be detected and thereby we will gradually improve our knowledge about the anomaly class. It works on structured data and time series data. In the first case study, we show training and test of a thresholded variant of KNN on a two-dimensional data set. First, we configure our workflow. On the left-hand side, we have our modules. On the right-hand side, each module has a property grid where we can configure it. Here we configure the workflow such that we read in the data, we normalize the data, and we use a machine learning model, the thresholded version of KNN, and configure it. We store the knowledge base in a file and then we start training. Now this training takes place on the training set with normal instances only. After training, we test. We read in the test data and we get the results like the confusion matrix and further metrics. Here we see the data visualized, and we have a distance view which shows sort of like a confusion matrix. In the second case study, we work on anomaly detection on real-world automotive data from road trials. That sort of data is being recorded either using an OBD interface or by connecting a data logger or laptop to the vehicle's network. We have previously trained our workflow and now we test it with the test data. The workflow consists of normalizing and using a one-class support vector machine, which is called SVDD. And here we see the results with data points being either reported as normal or abnormal. In the third case study, we use visual analytics to analyze time series data. Again, we use the data from automotive trials, and the toolbox offers a variety of visualization. The data can be interactively highlighted and that can be propagated to different visualizations. For example, here we query for those time points in the recording where the velocity was above 50 and the accelerator pedal was below 10%. Now users can select from a variety of configuration possibilities and have different visualizations. Some more features of our tools is the possibility to work on time series data with different filters, pre-processing or transformation methods. In addition, the toolbox has a workflow queue that shows all workflows. These workflows can be run locally on a server, and each workflow generates a report for reproducible results. For testing purposes, we can generate time series with a visual pattern generator. And we can add noise to that. We can also visually query for time series given a user-specified pattern. Now that was OCADaMi, one-class anomaly detection and data mining toolbox. A paper was published under the same name.